Right, so in this one I am starting to write the texture pipeline for the game and the engine, which requires a few components. So one of them is another Visual Studio solution in a project, which is going to be utility toolkit. In there will be code that I reuse from platform to platform and game to game. So texture loader is a prime example of that. Here I'm just having a look at the source code in the D3D tutorial to look at some information about DDS. Starting here, putting a new visual assembler and SVN repository to store the utility toolkit, and then I'm copying the make projects and the batch files and stuff from the other solutions. Also created a environment variable to use on the different projects or games, so I can know, or on another machine you could install this as an SDK and know where the libs live. And also I'm adding in a blank header and CPP into the Visual Studio project of the utility toolkit called loader, and that is going to have the header and the source code of the texture loader. Fairly quick process to just create a new solution with pre-make, and it's all quite neat and tidy. I much prefer the layout of the structure directory than how Visual Studio does it by default. And I much prefer having sort of common settings and build directories and stuff just come with me also automatically. So what I'm doing is creating a struct here, texture creation params, which has all of the information that D3D needs to create a texture object and a shader resource view, so you can use it in a shader. The texture loader is basically going to open a file and give me that struct and give me the data as well. The texture data, that is. As I've just created this solution, I'm just getting the project to build and hooking it all in to the game project, so I can call a function and make sure basically the pipeline's in place for using the utility toolkit from in a different project. And the process was really quick, so I think pre-make has already proven itself invaluable. Because it works straight away, and sort of I've done this sort of stuff before just in Visual Studio, setting up build directories and stuff, and it's just fiddly and not very nice to do. Here I'm just fixing the working directory that gets used when you launch from the debugger. So that lives in the same folder as where the exe gets built, and so does the data. So everything's consistent wherever I run the game from. It will work. So I'm duplicating the DDS header in my own code so I can port it more easily. And I can use the DDS format on any platform, because it's really just this header with some information that I can interpret the data with, and then it's just a big block of data, which is the pixels or the texels of the images. And then I'm using that information from the DDS header after reading it from the file. I'm using it to fill out the texture creation parameters struct, which D3D will accept and be able to create a texture object from. So when I get it in the game and pass it into the engine, I'm not really doing all that much with the data. I'm just passing it straight through to D3D. On different graphics APIs, if I was porting the back end of the engine, then they wouldn't necessarily fit D3D, so I'd maybe have to transform the data slightly, but it's quite an optimal set of data, I think. Just fixing the path of the shader file names so they get built into the correct directory. And trying to keep every single thing tidy as I go along, like data directories, projects directories, and the source code and everything, because so often some part of it or all of it will go messy, and it just makes you not want to work with it, or if you go away and come back, it's a bit daunting. So just trying to keep tidy and move along in small increments, but be thorough along the way. So yeah, here basically it's working. The toolkit and the data and everything is working. So now the pipeline's in, I can get back to writing the code. DDS format can store information about compressed textures or different texture formats and bitmaps and cube maps and all this kind of stuff. That's why I went for it. And then I plan to use, or I do later on, use NV compress to compress the images, or to write out DDS files and generate bitmaps and all that kind of stuff. So it's nice to just have a format that can support a lot of things I need. Using DXT compression can be a good win often, because it means you get better texture cache utilization, especially when you use a swizzled block format, like on some consoles. You can swizzle the DXT blocks in Morton, Z order and or different curves like that, and get even greater texture cache utilization. I'm not quite sure what happens on the PC version of DirectX. I'm going to have a look into that. But the first texture I end up loading actually happens to be a DXT1, which is I was actually hoping at first it'd be an RGBA image, just because it might be easier to debug if it hadn't loaded in or something. But it worked out okay, and it just means that I've got compressed images from the get-go. So the DXT identifiers are written in hex out of ASCII characters. So in the DDS header there's a set of flags, and they say DXT1 or DXT2 or whatever in hex. So I'm just looking in the ASCII table and doing some hard-coded hex for these. And some code in there to convert the DDS texture format definition to the D3D definition. Here I'm having to calculate the size of the texture of the top level MIP and the size of the extra data that comes after that, which may be a MIP chain or a series of cube map faces, or a series of cube map faces with MIP chains, or depth textures or texture array slices. So for the time being, I'm just going to support MIP-mapped textures. I'm not doing cube maps just yet, but I will do them. But it just means I have to loop through the MIP maps and work out the size, so I can copy the data and then pass it to the game. And then I will also need to use this same arithmetic to work out the size of the MIP map, the images and the MIP faces, and the offsets between them to pass to D3D to update the sub-resource. I did try and pass the whole lot in one go, but it didn't seem to work. So when I pass it to D3D, I just have to iterate over the MIP maps one by one. Some missing flags that I didn't pass to the D3D device. Having the D3D debug device is really useful. It gives you loads of information. For a while I was still using D3D10, and they kind of stopped the debug device working after a Windows update. I don't know quite what happened, if it was my drivers or something, but I couldn't create a debug device basically. Maybe with an SDK update as well. So it's nice to have that back, because sometimes I was just kind of having to manually recheck things, and it does save quite a bit of time when you pass bad parameters to creation functions. D3D will just tell you what's up with it. I'm just creating the commands here in the rendering API, in the direct and the deferred API, to be able to create a texture 2D. So the create texture 2D function takes a struct of texture creation params, which was filled out by the texture loader. The reason I didn't just have so I've got two functions you have to call. You have to go create a texture from file, and it gives you the texture creation parameters, and then you pass that to the renderer and say create a texture with these parameters. The reason I didn't roll it all into one is because probably I want to have the loading it from file on another thread, and then when it's ready I'll pass it to the renderer. So keeping things separate, like the renderer is only doing rendering, it's not doing file loading basically. Here I'm just having to add a pitch parameter to the creation parameters of the texture, because when I pass my texture data to DirectX, I need to tell it the pitch of the memory, and I need to work that out. I think in the end pitch wasn't enough. I need to know the block size of the texture. If it's a DXT compressed texture, a block is 8 or 16 bytes, and you only get a minimum block of 2x2 texels. So it didn't make working out the pitch trivial. I need to work out the pitch of every individual MIP level, so I think that's why I needed the extra data. Yeah, so finally I needed block size and number of pixels per block. And then from the width and the height, I can find out the pitch of the MIP levels, because I can work out their size. But originally I was trying to do it just based on pitch and trying to like reverse engineer the block size and stuff like that. I could have just checked the D3D type, but I didn't want to write quite like that much code basically. And then this free texture just frees the CPU side buffer that stored the texture data in whilst we passed it to D3D. Then of course I need to add a text coord parameter to my vertex buffer and my input layout. I need to create a texture shader which takes a text coord parameter. In the shader I also need a texture 2D and a sampler. So it didn't quite work straight away. That's what I'm debugging now. In the end, I think it was my stride of my struct or something like that was incorrect, basically. Yeah, the struct was the incorrect size. And then there's the rendering out the text coord slightly incorrectly, I think. And now I'm just using a D3D sample to just get the function calls I need to use to bind a texture and set a sampler. I need a shader resource view in D3D to be able to use a texture in a shader. I'm using some of my own code as well. here I was having a nightmare with assert on the HR failed macro as well. I was just so confused about what condition it should be for it to fire the assert. In the end, it should have just been a pen assert HR, because HR is 0 when it succeeds. Generally, I can't really be bothered with error handling. It's useful to have them on the D3D things, because at the moment I'm kind of implementing this functionality and checking if they're working and stuff like that. But I don't really like writing it all for my own code, and I don't think I'm going to have loads of it in my engine, because I'm going to be using it myself mainly, so I'll be able to just step through a debugger if something goes wrong. So at this point I'm just hard coding in, before it renders an index buffer, it's going to bind a texture, and there it is on the screen, textured quad, and that's all through the deferred rendering API. So the call's made on the game thread, the D3D call is made on another thread, and then it's rendered on the GPU. In the console there's a load of spew about a sampler not being bound. And that's all basically. Texture rendering on screen. It's pretty good going. I think quite a long session. I think in total it was like 4 hours, 3 and a bit hours.